Alright, this is the radical terms where there are radical terms on both sides. We approach this very similarly but also a little bit differently. When there are radical terms in the same equation, we're going to separate them on opposite sides of the equal sign or equation and then take care of business. We're going to square both sides. We're going to square both sides so that we can eliminate the radical symbols. Then we're going to solve it normally and naturally. We're going to square both sides since both of these radicals are on separate sides. We're going to square both sides, and what does the squaring do? The square roots and the squares are going to cancel. The square roots and the squares are going to cancel. The new equation is 4x minus 15 equals 5 minus x. This is a linear equation with variables on both sides. I like to cancel the variables first, just in case there's all real number solutions or no solutions, either special cases. Since these are different x's, these will combine, and all of our variables did not cancel out, so this is not a special case. This is a regular equation. That's why I like to always do the variables first. 5x equals 20. Last step, divide by 5. X equals 4. And if I wanted to check this, again, always check in the original. The square root of 4 times our answer 4 minus 15, is that equal to the square root of 5 minus our answer 4? We're going to operate underneath the radical. Multiply, then subtract. 4 times 4 is 16. 16 take away 15 is 1. The square root of 1 is 1. So if the right-hand side equals 1 also, we know our answer works. 5 take away 4 is 1. The square root of 1 is 1. So 1 equals 1. That means this answer worked. Moving on to exercise 2. Both radicals are isolated on opposite sides, so we're going to square both sides. The square root and the squared are going to cancel. Negative 3x plus 67 equals 11x minus 3. Put the variables on the same side. It doesn't have to be the left side every time, but this time today I'm going to always put them on the left side. Negative 14x plus 67 equals negative 3. Subtract 67 on both sides. Negative 14x equals negative 70. Last step, divide by negative 14. X equals positive 5. If I plug 5 back into the original equation and do my check, it should work. Negative 3 times 5 is negative 15. Negative 15 and 67 is 52. So the left-hand side is the square root of 52. We could simplify it, but I just want these numbers to do two things. I want the left side and the right side to match, and I also want it to make sense. If this were a negative number, that would be a big problem, wouldn't it? Now we're going to do the 11 times 5 is 55, and 55 take away 3 is 52. So we have 52 on both sides of the equation underneath both radicals, so I know these are equivalent, and these are real numbers. You can square root 52, you can simplify the radical, but because it's not the answer, it's the check, we don't need to do that. That just verifies that our answer is correct. There are 4 exercises for you to try at the bottom. We're going to take a look at 2 of these exercises. We're going to start with number 1 and then do number 3. Oh, I'm sorry, I circled number 2. We're going to do number 2 and number 3. Both radicals are isolated on opposite sides, so we're going to square both sides. The square root and the squared are going to cancel each other. X plus 80 on the left, x plus 56 on the right. It's a linear equation with x's on both sides. We're going to collect them, subtract x from both sides. Then I get 80 equals 56. Wait, where did all my variables go? When all of your variables cancel, you have a special case. Is this statement true or false? When it's false, that means this equation has no solution. This is the reason why I always cancel the variables first. If I move the 80 to the other side, before I move the x, I'd be doing an extra step that was not necessary. Our last one we're going to look at, number 3. We have two radicals, they're by themselves. We're going to square both sides. One of the things you learned today is to square both sides of an equation. That will cancel the radicals because square rooting and squaring are inverse operations most of the time. So we have 5x minus 9 equals 2x plus 21. Now, why did I say most of the time? Isn't it all of the time? Not exactly all of the time. So we are going to have to be careful. We do have to be careful that our answers work. We're going to move our x's to the left. So I get 3x. We're going to add 9 to both sides. 3x equals 30. We're going to divide both sides by 3, and x equals 10. We're going to plug this in. We'll do a check. 5 times 10 is 50. 50 minus 9 is 41. You can take the square root of 41. That's a real number. We'll do 2 times 10 is 20. 20 plus 21 is 41. You can square root 41. And both sides match, which means our solution is 10. You could practice these other ones, but I'd rather spend the time to look at your homework. Turn to the next page, page 28. What you're going to do is you're going to solve your radical equations. Everything on page 28 has one radical sign. So you want to first isolate the radical. Then you're going to square both sides. Then you're going to solve the equation just like normal. And the last thing you always want to do is you're going to check your answer. Please check your answers to receive credit for your homework. You have to do that. There's one radical on top of page 29. Number 6 is the last one with one radical. Before you square both sides, you have to isolate the radical. Starting 7, 8, 9, and 10. Now there are two radicals, just like the second part. They have to be on opposite sides before you do anything else. You're going to square both sides after you isolate the radicals and solve it as normal. You're going to check all these solutions. So why did I say most of the time squaring and square rooting, these are inverses of each other? If you take a number and you square that number and then you square root that answer, do you get back the original number? Let's find out. Take 7, square it, you get 49. Take the square root of that number, you get 7. You get back the original number. Let's do another number. Let's do like 15. 15 is the number we start with. Square that number, you get 225. Square root 225, you get back 15. So these are the same number we start with. Is that always true? What if I choose like negative 4? If I square negative 4, I get positive 16. And if I square root a positive 16, I get 4. Do I get the same number I start with? No. So squaring and square rooting are inverse operations only for positive numbers. So it may be necessary to do these checks because sometimes we get an answer that may not make sense. That's just for you to hear about for today. We have one more lesson. Day 8 notes will talk more about why this opens up a bit of Pandora's box for our solutions. Please do your homework, and I will see you next class.